Hello everyone, welcome back to this channel. So let's continue our Kaggle course Intro to Machine Learning. As of now, we have completed how models work. We have read the tutorial. We have seen that how a decision tree is used to make a prediction of any housing prices and what is training data, what is known as fitting or training the model and how to predict the things. And after that, we have done this one basic data exploration. So here we have imported pandas. We have taken a housing price data set of Australia, Melbourne, and then after that, we have just seen the data by using the describe function and how to calculate mean, standard deviation, all these things also we have understood. Okay, and then we did the first coding exercise. We have reviewed the data by using describe, and also we have seen something like average, what is the average lot size, how old is the newest home, all these things we have done till now. Now we are going to study your first machine learning model. First I will read, then we will do the exercise. Okay, so your dataset had too many variables to wrap your head around or even to print out nicely. How can you pare down this overwhelming amount of data to something you can understand? Simply your dataset is too large. So you have to do something so that you can understand what is inside the data. Then only you can do the prediction. Now we will start by picking a few variables using our intuition. Later courses will show you statistical techniques to automatically prioritize variables. To choose variables or columns, we will need to see a list of all the columns in the dataset. Which column we are going to choose. So before choosing anything, you just have to list the columns. You have to see which are the column names, and that is done by using the columns property. See, import pandas as PD. You know this. Melbourne file path. This is the file path where the CSV file is located. I mean the CSV data set. This is the CSV data set. We are going to read the CSV dataset and convert it into a data frame. What is data frame? Data frame is a collection of rows and columns. So Melbourne data is a data frame right now. Okay. Now I want to see the column property. So Melbourne data dot columns. This one will give you the name of the columns. So you see here. In this dataset, we have these columns: suburban area, address, rooms, type, price, method, and many other things. Okay. So now read what are the things written here. The Melbourne data has some missing values. We will learn how to handle missing values. Your data doesn't have any missing values in the columns you use. And so we will take the simplest option for now. Drop houses from our data. And don't worry about this much for now, though the code is, they have just said that in this data set there are some missing values. So working with those missing values you may face some difficulties. So for simplicity right now you can simply delete the missing values. Okay, and later on you will learn how to handle the missing values. So for that they have used this column. This is the data frame dot drop now. That means delete all those values which are missing. Okay, now there are and what is the meaning of x is equal to 0? And what is the meaning of x is equal to 1? If you know, let me know in the comment section. Though I have told in my previous video. Okay. Now there are many ways to select a subset of your data, and the pandas course covers in more depth. But right now we will focus dot notation to select the prediction target. Prediction target means your output. And selecting with column list, which we use to select the features. That is the input. Input is also known as features. Like in the housing pricing data set, the location, the size, the lot area, the bedroom, all these things are features. And the price is the prediction or the output. Okay. Now, how to select the prediction target? You can pull out a variable with dot notation. That means, see here, you have a column called price. You know that this is your output. You want to know what will be the price. So what you do here, you just write the data frame dot the price column. So the single column is stored in a series, which is broadly like a data frame with only a single column of data. Series is nothing different. This is simply like data frame, but when your data frame has a single column of data, only price or maybe only location, like this, that is known as series. So here we will create a series of the prediction target. That is this. Okay. So we will use the dot notation to select the column we want to predict, which is called prediction target. By convention, the prediction target is called Y. So the code we need to save the housing prices in the Melbourne data is Y equal to Melbourne underscore data dot price. So this is the data frame. This is the column. You are creating a series, that is the prediction, and you are keeping it in Y. Okay, I think this is completely clear to you. Next, choosing features. The columns that are inputted into our model are called features. In our case, those would be the columns used to determine the home price. Sometimes you will use all the columns except the target as features. Look, in your data set, maybe some columns are necessary and some columns are just like that, like the ID. And many other columns may be not so much important to predict your output. So in those scenarios, all you have to do is select the columns, the specific columns which you need for your model. Okay, that is known as choosing features. So here you are just making ready of your input. That is, I can say in the simplest language, you are just creating your inputs. Okay. Now, sometimes you will use all the columns. If your data set has has many columns, all of them are necessary. So there you will take all the columns. No problem with that. If you think that some columns are not necessary, then you will simply remove them. Okay. So other times you will be better with fewer features. Now for now, we will build a model with our only a few features. Later on, you will see how to iterate and compare models built with different features. We select multiple features by providing a list of column names inside brackets. See here, we have created some features and we are taking rooms, bathroom, land size, latitude, longitude. Okay, so I am just creating my input by taking the features, by choosing the features. Okay, and the rule is that each item you have to write in a string with quotes. Okay, these are in string format. Fine. Now, by convention, this is called as X. You can give any name, but you will see that inputs are naturally given us, so normally given us. By convention, the data is called X. So you can see that conventionally we use X for inputs and Y for outputs. Okay, so whatever features you have created, you are just taking those values in input. Fine. Now let's quickly review the data we will be using to predict the housing prices using the describe method. Okay, so if you write x dot describe, that means you are taking all these columns and describe function will give you these measures, these statistical measures. Perfect. X dot head will show you first 5 rows or of this particular features. Okay. Now visually checking is a data scientist job. You will frequently find surprises the data set that deserve further inspection. Fine. Now building your model. How to build your model? You can use the scikit-learn library. Scikit-learn library can be also written as sklearn, as you will see in the sample code. Okay. So this is very popular, and the steps to build a model is first define what type of model it is. You can use linear regression, logistic regression, decision tree, SVM, anything. So here they have used decision tree because it is simple. Now fit. Fit capture patterns from the provided data. This is the heart of the modeling. When you are training the model, it is actually fitting the model. Okay. After you have fit the model, you can predict. So predict just what it sounds like. And next you will evaluate how much accurate it is. Because how to evaluate? Because you have real data, so you have some real output. But after using the model, you are getting some predicted output. Now you will compare them, the actual output, the predicted output. That is known as evaluation. So you can understand how much accurate you are. 80% time you are accurate or 90% time. Okay. So here you can just write from sklearn.tree import decision tree regressor. You are just importing the model. Okay. Now you are applying the model and you are using random state 1 so that every time you get the same output. And after that you just fit it. And to feed the library, you have to use only a simple code. Feed x. What is x? You have just studied. X is the input, x is the features, and y is the output. Okay. So now many machine learning models allow some randomness in model training. Specifying a number for random state ensures you get the same results in each run. This is considered a good practice. You use any number, the model quality won't depend meaningfully on exactly what value you choose. You now have fitted model that we can use to make predictions. This thing I have already told you. This will give you the same result. That's why we have used a random state. But okay. Now see first print making prediction for following five houses. Okay, this is the prediction you have printed by x dot head. Okay. So Melbourne model dot predict and x dot head. So you can find what are the predictions for the five houses. Okay. So if you have two rooms, one bathroom, 156 land size, this latitude, longitude, your predicted price will be this one. Okay. Now let's do the exercise. So first you have to set up the exercise. So let's just run it here. Recap. So far you have loaded your data and reviewed it with the following code. Now input pandas. This is the file path. This is the read CSV. You have created the data frame. Home data is your data frame. Perfect. Now specify prediction target. We have just learned how to denote this. Okay. Select the target variable which corresponds to the sales price. Save this to a new variable called y. You will need to print a list of the columns to find the name of the column you need. Okay, so first you have to uh, print the list of the columns. That will help us to find what is the output. How to do this? See here. We have just learned here. You have to write dot columns. Okay, so here, what is the name of the data frame? Home data. So simply write home underscore data dot columns. Now let me run this. Perfect. Now read all this and understand which one is your output. So the output is there will be something called price and sell price. Okay, fine. So set your output. So you can write, you have to specify the prediction target and save this variable to y. So y equals to home underscore data dot and sell price. Okay, this is case sensitive. Okay, so once you have written this, perfect. Your prediction is set. This is the output. Your output is set. Now what you have to do? You have to create your inputs. Now you will create a data frame called X holding the predictive features. Since you want only some columns from the data, so you can give the name X and these are the columns you have to use as your features. This is choose the features. Okay. So now here we can write feature names equals to, how to write this? Let me show you once again. Like this. Within the third bracket has a string format written in quotes. Perfect. So if I copy this and if I paste it here, I have to write all of them in quotation. Okay. Right. Okay. Okay. And last one. Fine. So your feature's name is done. Now you have to write it in X. So X equal to the name of the data frame, and features data. Sorry, features names. Perfect. Now let me run this. Mm, it's not features. I'm so sorry. Okay, perfect. Now review the data. It is always good to review the data. So before you build a model, you just give a look that X is perfect. We will also see that Y, whether Y is also perfect or not. Okay. So what do you have to do? Mm, you can write X dot describe. What is the running option? Sometimes it doesn't work. Leave it. Just let me write a code here. It's not describe. Okay, perfect. Let me see Y. Otherwise also single column. This is known as series. As I said, same like data frame, but having only one column. So your X is set, your Y is set. To print the top few lines, you have to write X dot head. Okay, you just let me show you. Here it is not working. It's dot head. That's fine. Okay. These are the columns you have chosen. These are the input features. So now your input feature is ready, your X is ready, your Y is ready. This is X, this is the input, this is the output. So you have input, you have output, now you have to fit your model. Okay, now they have said to fit the model, just like that. Mm. This is the way you have to fit the model. Okay, so let me write this. From you are using decision tree regressor. So decision tree is in this package sklearn.tree import import. Copy this decision tree regressor. Okay, now Iowa model equals to say give the random state. So that this is not mandatory, but it's a good practice. Okay, you have to fit the model. Iowa model dot fit x comma y. Okay, single line of code giving the input, giving the output. So you want to say, see the input, see the output, find the pattern, train my model. You're done. Perfect. Now make predictions. So to make predictions with the model's predict command using x as the data, save the results to a variable called predictions. Okay, so IOR underscore model dot predict. What to predict from the input. So they are saying that consider X as the data. Sometimes you may use new data, but right now just your model is trained. So you have the model. Now you are using that model. This is the model. You are using prediction function. So you will write predict and you are passing X as the data. Perfect. Now let me run this. So this is the prediction. So you are done. Okay, now think about your result. Use the head method to compare the top few predictions to the actual home values in Y. Okay, so you can use Y dot head. See, if I write this, you can see 208500, 208500, 181500, 181500, 223500. Okay, so it is predicting. So nice. Perfect. I can give you a task. You just write a dictionary and in one column you print the actual values. In the second column you print the predicted values, and then you compare. Okay, just for your comparison, this is your task. Try to do this. Now it is natural to ask how accurate the model's prediction and how can you improve that. That will be your next step. Uh you have set your output first, right? Then you have choose your features, then you have trained your model. After that you have also predicted your the values. Now you have to see what how is the performance, how much accurate it is. So for that you have to take the previous values, like the real values, and you have to take the predicted values, and then you can do this. Okay, so in our next class we will study how to do model validation. Okay, till then, bye, happy learning.